All right, good morning, everybody. This is much more energy than I was expecting in the claps and the feedback. So I want to remind everyone that I'm here because of Tim, John, the group that put this together to try and service something for you. So if you have any thoughts, questions, whatnot, raise your hand. I did my best to try and find a way to not overlap all of the wonderful information Northwest shared and the rest of the program today. But the information that I have isn't any helpful in my head. If you have a question, raise your hand. I'll be glad to help. This will be more beneficial for everyone if it's interactive. But the general intent of this session right now is to help you all understand where you want to focus your efforts, what you need to pay attention to be able to upsell the value of UHPC and make it a go on your project. Nobody wants their salesmen, their business development guys wasting plenty of hours and never getting anywhere, right? This is intended to help you increase your conversion rate so that we can see some more UHPC in the marketplace. So when we talk about UHPC and why we would do it, we're trying to knock on the value chain from top to bottom. We're increasing the durability of building envelopes. Right now, the structures of buildings can last 100, 120 years. We want to give them a durable envelope system that can last and doesn't need maintenance. Really within the engineer or architect that you're working with, within their career span, you don't want them to have to go out and maintain this. We want elegance. We want to be able to make all these beautiful shapes. Who knows that better than you guys, right? Every time I see the awards, I mean, it's just awe-inspiring shapes. UHPC can continue that trend. Detail. Architects love to make things, I'm a structural engineer by trade, so I'm going to say painful. You guys will say beautiful maybe. But that level of detail, that's really where things pop off the building and people pay attention. That's where you get the award-winning projects. And strength. Really the value chain for UHPC all stems from its strength as well as durability, but increased strength, less volume, cost savings, etc. But really what we're talking about is value. You're never going to sell anything if you can't convince the owner that it has a higher value. All of you have probably heard I won't call it a misnomer, but the statement, UHPC is really expensive. Initial cost, throw it out the window. We want to talk about value. If you were going to go and try and race on a racetrack, you're not going to go buy a Toyota Camry because it's cheaper. You're going to go and buy a Corvette. Right? It's all about what you're trying to accomplish, and then the price tag has to fall in line with that. So again, value. What are we talking about when I say value? It's an inclusive measure of the efficacy of a product, good, or service to fulfill an owner's need. That includes initial cost. They're never going to completely forget about initial cost, but it includes life cycle cost. If their product before was 25-year life cycle and this might get 75, that matters. Now, they're not going to say, okay, we'll pay 3 times that, but you might be able to get 15%, 20%, etc. It depends on the owner and their need. Life cycle assessment, drop one of the C's. Everybody's talking about sustainability, carbon, etc. Embodied carbon matters. The carbon associated with repairs, with other, being out of service. That matters now to owners. If you can ever tap on a buzzword, it's going to help your cause. And then the overall performance and future needs. That changes with every project. What I'm up here to talk about, and surely what you guys have gathered, is that UHPC is not the end-all, be-all. It is not the one-size-fits-everything. There's always going to be a market for traditional concrete. There's going to be a market for GFRC. It's all about identifying the needs and aligning properly. System optimization. GFRC oftentimes needs steel frames. Regular concrete needs to be very heavy and can increase the load that your building structure needs to be able to carry. These are the things that you want to get beyond just initial cost of UHPC. You want people to look at the cost of their building envelope system because you can have positive impact up and downstream. Now I'm going to give you an example. Again, infrastructure is where I live and breathe. So don't hate me, this is an infrastructure example. But in New York State, when you have more than 25,000 AADT, which is traffic over a bridge, they require that you switch to using stainless steel rebar. Now, they acknowledge right in that same section that it's 2.5 times the cost of epoxy, and yet they require it every time they have a bridge with more than 25,000 vehicles that travel over it. The reason being the cost of maintenance, repair, replacement is 10 times that of the cost of paying more for stainless steel bar if they're already there and doing it. That's the concept we're talking about here. You're talking about, hey, you have a big high-rise, you don't want to go in and touch this, you're in a congested area. Those are the places where saving money and not having to come back can be worth exponential amounts. So initial cost can be higher, but total value can also be higher. That's what we're talking about. And this is just a graphic intended to be kind of exaggerated. Many of you have seen bending tests, you know kind of what to expect, but what you're going to get with UHPC is great performance in bending. That's why we're here, that's how we can do this, that's how we can design it in and make it thinner and make it make sense to these owners and architects. Versus traditional concrete, which is very brittle. You may need reinforcement, you may need to be very thick, etc. That's what we're trying to get away from. So, today we're going to talk about identifying the value chain. It means we're going to talk about what do the owners and architects actually care about. You know, you can sit down and put together a great presentation and have this package, but if they don't care about it, if they're not inclined to hold value to that internally, you're just spitting in the wind, per se. Proper selection of opportunities. As I mentioned, it is expensive to have business development and sales guys constantly chasing down opportunities if your conversion rate is 2%, 5%, etc. So proper selection can drastically improve your internal return on the investment that is trying to do UHPC. Production process design. We talked a lot about that yesterday. You got to see how Northwest Precast does it. We'll talk about that a little more today. Master craftsmanship. I'm not even going to pretend to talk to this crowd about that. You guys, please tell me everything you want or can share with me because I want to learn from you guys there. But of course, it's always going to have a role in your value chain. And then last is quality control and risk mitigation. So, step one, value chain. UHPC is a concrete solution. What does it mean if you have a solution? You started with a problem or a challenge or something you wish to improve. So, what's required to leverage this? The owner and the architect have to acknowledge that they have a problem. If the owner and the architect don't believe that they have a problem, you can quite possibly be wasting your time. You have to have a direct and quantifiable value add from that solution. You have a building that can't hold the weight. I have a solution that's lighter. Whatever it may be, but you have to be able to convince them that there is a tangible value and not just theoretical things that they can't touch or feel. You have to understand the value chain. What Vic and I like to say is we try to understand the market better than our customers themselves. You guys have already done that, right? Architectural precast is already paying a premium for something that used to be done more crude. It used to be done less pretty. Now they pay more for that master craftsmanship. This is not anything new, it's just applying it to a new material for you. So, you can quantify the sustainability or resiliency of the solution. Now those two words are often used in kind, but resiliency, right? We are having more natural disasters. We're having, windstorms with, in the desert, sand is a very abrasive material. You have hurricanes, things like that. Resiliency is the ability for UHPC and concrete in general to withstand that and still carry the structure after those natural disasters. The justification to get through the design process. You can't just say, hey, I have this idea, good luck, go run it down. The knowledge is not there in the industry. Tim talked a lot about them working with KPFF. We spend a lot of time working with Northwest Precast. There's only a few of, I'll say us, Vic and I and other people in the UHPC industry that are working to educate architects. By engaging the precasters, that number and your influence points are drastically increased. Right now we're exponentially increasing the influence that we can reach because we have more people trying to help educate. And you have to have the skills to communicate and deliver the solution to them in a manner that they can understand and be interested in. I can sit down and do a bunch of calculations and make the math make sense. If that's not how the owner, their representative, or the architect are wired, it doesn't mean anything. So that skill set, also what I want everyone to take away from today, it's different. It will look different for every plant, it will look different for different applications, and it will look different for different architects. I'm sure you all already have an architect that you love when their name comes across your desk, and others that you consider throwing the plans in the garbage. So those are considerations for this, just like anything else. What are we really talking about? Converting long-term value to short-term decision-making. A lot of these people are thinking about their career right now, their career for the next 5 years. They don't really care what happens to a building in 75 years. So you have to convert these longer-term things to a decision that they're going to make right now. They have to go stake their reputation back to the owner to say, hey, I think we should do this. What does a typical solution package look like? It's a value-engineered solution. There are projects that come out specified as UHPC, but most of the time, this is a substitution. You're bringing something to them, you're working through collaboratively to try and give them a better option. A lot of times it's delegated design. You're going to need a good industry partner to help you with this, just as you did with GFRC or any of the other architectural products that you do. Often, especially in this group, what we're talking about are panels that are designed for the building envelope. But it is far reaching beyond that. We'll talk a little bit about it. That's the most common. When you do this, a lot of times your connections need to be redesigned or at least adjusted. They're not exactly the same. Then you got to cast the panels and execute the project just like anything else. So while I'm talking about the intricacies and special application, I don't want this to sound scary. This is what you guys do. It's just a new material with new considerations. This is not a completely new ballpark. And then, as I mentioned, you want to understand the owner's value chain better than them, and who does that better than the APA? Pitfalls. What happens a lot of times is people limit what they're telling to an architect. You get stuck in initial cost. You get stuck on the one-for-one. They see a per cubic yard cost. Per cubic yard is where all value goes to die. Because if you talk about concrete per cubic yard, nobody ever talks about steel per cubic yard. They do steel per pound. If you look at steel per cubic yard, it's like 15 times more expensive than concrete. But architects know that they like steel, so they don't get stuck in that. They look at, oh yeah, well it's steel per pound. That's just what we know. With UHPC, we're still in the education phase. We need to get them past that. As I mentioned, there are other places downstream. I believe Gary is going to talk about it. Faster installation, fewer pieces, less truckloads. These are all things that can increase the revenue that you make as a precaster and reduce the total cost of the installed envelope for the owner. I just mentioned focusing only on initial cost or initial embodied carbon. Again, we're talking about a life cycle. We're talking about an all-inclusive thing here. Falling into the sunken cost fallacy. Well, it's going to cost me delegated design. I need to bring in expertise. I need to do something else I wouldn't normally do. You can still do that and end up with higher value. If it costs you a little bit more time and effort to get the first one across the finish line, this is the trend we're going. That knowledge is worth something to you. It's worth something to the architects and builders in your market because the second one comes around and it's cheaper. Under-communicating solutions. You're finding a trend here. These are the things that we see most common where jobs that are trying to be converted fall short. So, extending the panel span is a big thing that you can do here. That is not always communicated to the architect up front. It just says, oh, well, here's your per square foot. If you wanted 80 panels, you're going to get 80 panels. Doesn't need to be that way. 80 panels can become 60 panels. There's a value in that. So, now that I just beat that dead horse, let's talk about selecting opportunities, making the most value out of our sales and our business expenses. Here's just a couple of examples. The top is a yacht club in the Middle East. They have a panel that they want 60% perforation, they want a specific texture and color, and they need a certain amount of strength. They also, because I enjoy architects so much, don't want anything to be very continuous or linear. It's a series of, it's hard to tell from this picture, but it's actually rectangular perforations, but none of them align, so there are no linear supports from edge to edge of a panel. To do that, you need the strength that UHPC can provide. GFRC panels were originally designed, but the UHPC has a span of about 60% longer than the GFRC. The other thing was, as I mentioned, it preserves the concrete finish and the steel. This is a steel fiber project. Everything in the Middle East tends to be a rust color. So when this cracks, high carbon steel will rust, but it will match the color that the panels are already tinted to. So by using high carbon steel in this application, it's a high value for the owner. The one down below is a series of window returns on a building. It improved the thermal efficiency of the building. The strength of the UHPC was able to pull off some pretty sharp corners and deep window returns, as well as you can see the thin spacing between windows. They needed the strength that we had. They also cared about reducing the weight. And this was in a park in the Middle East. They needed it to be resilient and durable. This is a building that they spent billions of dollars on. They don't want to come back and have to touch it for a long time, and thus paying more upfront made sense. This project used almost 7,000 tons of UHPC. On the top here, you'll see this is a canopy for a train station in Calgary. It's another example of some of the shapes that you can accomplish with UHPC while also exhibiting freedom. You don't need a steel frame. You can have the strength you need. You can accomplish these shapes, have beautiful finishes. Another thing I didn't mention here, but architects tend to care about the PR of a project, right? They want to be in the news. They want to be regarded as doing something cutting edge, and they want to be the next famous architect people refer to. With UHPC being the buzzword right now, you can play on that. That can help bring allure to a project. And then down on the bottom, again, it improved the thermal efficiency. These were balcony shapes. Obviously, there's quite a difficult geometry there. It improved the strength, and it was another, extension of life and resiliency on a project.
Talk about improved thermal efficiency.
So UHPC has, you'll have to, on projects generally, if your architect is getting to that level of detail, you'll have to find your R² value. But with the thickness of UHPC, you can reduce the thickness compared to regular concrete, but compared to maybe dual paned windows on certain things, you can retain more heat within the building. The city of Vancouver, I believe, just instituted that you can no longer, it used to be you had to have 10% solid on your building. Now it's 40% for thermal retention of heat.
So what's the R value for the UHPC?
I don't remember off the top of my head, but I can get that for you after. Yeah, but it's.
You still it requires insulation behind it.
It's quite common, yes, but the solution will all determine on how the building envelope is done. Like I believe Tim mentioned yesterday, what they're seeing a lot now is architects are moving away from mounting the building, spray foam insulation behind. They're going to where the insulation is behind the rain screen and now the panel's just being hung externally. But yes, you can still use additional insulation. When I say improve thermal efficiency, generally it's relating to projects that otherwise would have been glass. This is related to conversion because for regular concrete, you guys already do that, right? That's one of the values you bring versus glass or other facades. So.
And the two things, so what you're seeing after years of so much glass cladding, is moving away from it to create more solid cladding so that the amount of heat that would get generated into the building is less. Is that what you're?
It's actually the retention of heat within the building. So like in in glass, heat can escape in the winter, and then I believe in the summer, the intent is also that, through glass, it can generate more heat into the building, the sunlight, et cetera. So it's supposed to reduce the overall heating and cooling costs of buildings by having less, clear glass.
Is that because of the makeup of the UHPC? It would seem interesting that UHPC panels would conduct less heat loss than glazing. You're saying that would be the case?
Yes, that's what we've found, and that's what we've seen in Vancouver, and I know there's a second city that's moving in that same direction. That's why they're trying to move away from the double pane glass or whatever it is that they're doing.
And on this topic of thermal, how does UHPC move from a thermal standpoint versus GFRC or traditional architectural precast?
Well, the thermal coefficient of UHPC is slightly larger compared to regular concrete. So under the same temperature swings, in theory, it will expand or contract slightly more. That delta is not huge. It's not a factor of 50%. I believe it's something like 15 to 20%. But with the lesser mass of the panel, it's going to depend on the size that you're doing. Generally, though, in a cladding environment, it's not something that'll be detrimental, that the expansion will cause cracking or, it's not to that magnitude. It won't cause you to lose continuity in your joints with, it's not going to push your caulk out or something like that.
So what size of caulk joints recommended?
Generally, that's similar, I would say, to what you would do with a traditional GFRC or concrete. That thermal coefficient is close enough that if you might have had 1/8 of an inch of thermal expansion going from 30 degrees to 100 degrees, you may have 5/64 or whatever that is. It's not enough movement that you need to redesign your joint.
What are the biggest panels you see them doing?
That entirely depends on the thickness. So at 5/8, we see 4x8, 4x12 is pretty common. It also depends on your insert spacing, but they've done panels that are 30 feet long. They just become thicker. You may also then push from a synthetic fiber into a metallic fiber. So the short answer is you can meet most envelopes and ranges. You just have to change some variables.
Just to expand on the thermal question, so the building codes are becoming much tighter and don't allow for the use of what was traditional double pane glass or insulated glass. So that's forced the insulated glass and the curtain wall companies to have better, more thermally improved curtain wall systems, which have become extremely expensive. So jurisdictions like New York City and Chicago and San Francisco, their codes have gotten more strict, which have pushed for higher curtain wall costs. So the option then is to put more opaque cladding on the walls. And that's where a product like UHPC or any other type of opaque cladding comes in. But where this product really has a nexus is the fire codes are also getting more strict. So this is a non-combustible product. A lot of your other cladding products and types are combustible and can't be used. So like in New York City, particularly Chicago, they all have to be Class A rated claddings now within the city limits. So concrete, whether it be UHPC or architectural precast and other forms, is going to have a bigger moment in the years to come.
That's a great point, and I'm glad you brought up the fire. These are the trends we're seeing. So the intent is to try and get out in front of it and have a solution. So that was Craig, who was just speaking from Envel Facade. They do a lot of this work, and that's a good insight into the value chain that they've seen to be able to convert UHPC flat panels.
At the same time, there was a PC, just to speak to what you said, we were at a PCI conference a couple weeks ago. And one of the things they were talking about actually is that any of these precast GFRC they will fail in a fire situation, especially if you're using metal. So they're
fiber for the cladding panels that we produce anyway, doesn't hold the panel together. It holds the panel together if the panel breaks. So it'll perform without that, but yeah, your point. So one of the things that has really forced a lot of jurisdictions to move away from combustible materials, if anybody remembers the Grenfell fire and, yeah, with aluminum composite panels, that's our other business. And that's happening all over the world. It just happened in Russia a few weeks ago. It's happened in Australia, Singapore. So a lot of jurisdictions have seen that and freaked out. And now we can't use any type of combustible material in high rises or anything else in big cities like that. So they're looking for other options and non-combustible options. And there's not a lot out there. So the threat to our aluminum business and cladding is now that instead of using those composites, they're using solid metal plate again, which is kind of old technology. But the other option is concrete and other natural products that are not combustible. So we're seeing a huge uptick in those opportunities. California as well, with all the wildfires going on. We're getting inquiries a lot from California. I mean, all the way down to residential stuff that, hey, we don't want combustible cladding in our homes and things like that.
Yeah, and I'll add that if you are targeting a widespread cladding market or something like that, it is quite common that you have to go through a process to qualify that your UHPC is going to meet IBC or an alternate. So you will have to do fire testing, and the presence of these synthetic fibers is really the way to achieve that. Under the heat, what happens is the polyfibers melt and they provide air pockets so that instead of spalling, the pressure can be relieved in these air pockets. But you can't just go and start doing 100,000 square feet of cladding in some of these big jurisdictions like Chicago and New York without going through some of that testing that's required by the IBC. I will add that is a painstaking process. Yes?
Staying on this thermal topic, how much have you run into the requirement to have a thermal break between the support clip anchor support steel and UHP panels?
I will actually kick that question to Craig if you're interested in answering.
Well, none between the panel and we would call it insulation curve, the cavity or the frame that makes up the cavity that you're going to put the insulation. Thin plastic on the stud wall, you have a standoff of some sort, and then the panel system. So that standoff is typically thermal. It gets back to the wall. And there's 5 or 6 different manufacturers. Some use like an FRP fiberglass standoff, some use aluminum with plastic thermal break. The panel itself and its own cladding or its own doesn't necessarily.
Yeah. So if you were to qualify a cladding system through that IBC process, as I mentioned, they may require that you actually select that material that's going to go behind in the standoff. But certainly, if you have more questions along that line, it's very detailed, but we can definitely have conversations for whoever in the room is interested. So common applications that we see, we're talking about flat panels, facades on a building envelope. Curved or perforated panels is a great place for UHPC to bring value, particularly, with the fibers that are distributed throughout the matrix. You can accomplish some of these perforations and things and still have enough strength to expand your span. We've seen cornice, canopy members, balconies, furniture. We've seen a lot of benches and tables, pedestrian bridges. That, of course, will be limited if you're not interested in building something that's 10 tons. You're probably not going to want to look into that pedestrian bridge market, but if you have the crane capacity and an interest in some of those custom things, a lot of architects are at least considering UHPC in their initial value proposal before sending their design back. So something to consider there. And then the last one is get creative. if you already approach markets and try to convert it to concrete that you're doing, you can likely find a place for UHPC as long as you can find somewhere that you're saving money down the chain. Good? All right. All right. So here's just a quick little checklist to walk yourself through. To make this happen, to convert this opportunity, can I reduce my panel thickness? Can I reduce the erection time or cost? Can I improve my field connections? You saw the French cleat system that Tim's using. That's a pretty sleek system, especially with the frame that they created to be able to get the panels up to the building without damaging them or having to take an hour and a half per panel to slowly creep in. Increase the panel size, enhance the geometry, right? An architect's rarely going to tell you to be less creative unless they're going for a very modern and orthogonal style. Reduce your heaviest pick. You know, you can go from something that might have been 8,000 pounds and bring it down to 5,000 pounds. And reduce the embodied carbon throughout the life cycle. So what it really comes down to is, can I make it cheaper? Can I make it the same price but make it better? Can I make it greener? Or can I make it a higher value? And to do that, do I have enough time? That's a big one, right? This is not just an easy one-for-one swap. It's going to require some time, some effort, meetings, etc. Do I have a viable and complete alternative? And the skills to communicate it. And have an owner that's willing to listen to it. And do I solve a problem? Or do I do it at a cost reduction, whether just for the envelope or the full scope? So, again, let's boil it down. Do I understand the product and the process? Do I have the documentation and the testing that's going to be required to satisfy the actual design? Do I need design assist? Do I need someone to come in and help, whether it be a material supplier or a KPFF? And do I have the time? Now we're going to go to the production process. This is still a concrete material. It's not a whole different product line. It's what you do. You just have to understand some of the nuances. Your lead times and procurement may be different. The development of a mix design itself, if you want to try and start from scratch, is not the same as developing an SCC mix or your standard mix that you know. It takes time. You want to make sure you understand that. Pre-production trials. If you want to try something, you certainly, with how expensive the completed piece is and how expensive the material is, you want to make sure that you get it right before you go to the project. You want to understand the design time internally. Is it going to take your drafters a little bit more time to get these done and get the tickets ready for your shop because it's a little bit different than what they've been doing? The anchor and the connection lead times. Northwest Precast showed yesterday they developed their own anchor. That's, of course, not picking up the phone and calling an ALP and getting them sent on the truck tomorrow. Batch math. This is one, it may have been discussed yesterday. I didn't catch it, so if I'm being redundant, wave your hand around and I'll move it forward. But when I say batch math, what that means is if you have a piece, you want to make sure that you can get material into that piece without a long layover, because you will have pour lines otherwise, or you may have discontinuous fibers which remove some of the benefit you get with UHPC. So whether you're pouring one piece or you want to be pouring 12 pieces, you want to make sure you understand how much material your mixer can hold, how much you're trying to get down. Do I need one batch, 2 batches, 4 batches? Am I 90 pounds short of the dry input I need to get this done? It's a little bit more important to get that math and that understanding down when you're using this material. Certainly if you're just getting started, you are going to have a couple times you're going to have to learn the hard way, where you pour something and you'll see what will and will not create a pour line. You'll understand what your tools are and your levers are to avoid pour lines in the event something happens. Because if you believe that everything will always go perfect, you haven't been in precast. So I know you guys all know you got to be able to react and have levers. Does that make sense? Does anyone have questions on batch math? It's really a more specific, it's right before production. It's very specific to your equipment and your pieces. But if you take anything away from this, remember that, because It's a real heartbreaker when a single small pour line can otherwise ruin what was a beautiful piece that you created. Form design. You saw some forms at Northwest. They have learned as they went, right? They tried a broom finish and they just couldn't get the air bubbles out, and they tried a couple of things and they went a different route. So understanding what it's going to take, how the material will behave with it. If you're already pouring SCC, the water tightness is about the same. But if you're not pouring SCC yet, you want to make sure your forms are watertight. You want to understand you may have to backform this or pour it on its side depending on what you're trying to do. And then again, depending on your setup, you want to understand, is this going to disrupt my mainline production? Is me pouring this UHPC going to fit in my workflow as it does at Northwest? Or do I have to stop everything else and go and focus on this for 3 hours and then come back to my mainline production? Those are the things that you want to think about and understand before you get yourself too far down the road. And now I'm pretty much done on production design because Tim and his crew covered it yesterday. They did a great job, so I'll thank you again. If anyone has specific questions on production design, I can definitely talk about it tonight on the dinner cruise. I heard that APA isn't picking up drinks, so if you guys pick up a drink, we can talk about production design. Master craftsmanship. I already covered this. There's nothing that I can add to this group on master craftsmanship. You guys are the craftsmen. You create beautiful things all of the time. The only thing I can add to you is that seeing is believing, both for yourself and an architect. We saw honed finishes. We saw acid etch finishes. We saw form liner finishes. These are all things that you already do. You just want to learn how it behaves with UHPC versus what you already know and love. And then the other thing is set your expectation with the architect. If an architect has never specified UHPC before, you want them to come and look at a mock-up. You want them to understand what it means that there's fiber in there. If you're standing at a honed finish and you look at it straight on, you may not see the fiber. Stand at a 30-degree angle and you're going to see the fibers glimmer. That is not necessarily a problem, right? Architects are doing it throughout the country and throughout the world. It's about making sure they understand it up front so you don't get a call down the line and say, hey, what is this? Why do I have it? It's not what I wanted.
So before you move on, your discussion about disruption in your normal operation.
Yeah.
Just seeing the batching line yesterday, can't imagine how it's not a disruption. And what have you seen or others do to mitigate that?
Sure. That's a great question. So the first answer is it all depends on what your mixer equipment is. So, when they mixed yesterday in the small turquoise mixer, it's called an Eimer. That is something that is outside of their main batch plan. So they could have been batching SCC or whatever else they wanted to do while they were batching in the Eimer. But of course, that's an output of maybe 1.25 cubic feet. The alternative, they have two mixers. So if you have a system where you can be batching in both simultaneously, you batch one mixer and you sacrifice one instead of doing two for your SCC. The alternative is you find a solution that can work for you until you do enough volume that you can then invest back in whatever process is going to fit. I know nobody wants to hear, invest back and spend money, but the truth is, if you want to do this on a large scale, it will likely require you to reimagine how you're batching a little bit, but you can certainly have a solution before you get there. You can be doing UHPC without a major investment, and then if it becomes the core of your business, that's when and we have Dan here, we have EZG, we have Vollers as an APA member. They can definitely help you. If you were to engage with Cientech or another material supplier, that's a lot of what we try to do, is make it fit your space. Does that answer your question sufficient? Yeah? Okay.
And if you're pouring like the dock flanks, 3x7, and it's a single plane, it's an inch and a quarter, inch and a half, the casting process is a lot easier than when you're pouring lifts for ribs and some additional structural, which is what they were doing yesterday, which is
Yeah, that's a good point. I mean, there was a section that we saw yesterday with a return on the panel. You got the opportunity to see how the material pours down and how it can flow, but it required time and effort. And when you're pouring flat panels, you can pour this down and let it run, similar like an SCC, spend a little bit of time finishing it and move on. It's all about, redesigning it to fit your process. The term is ultra high performance concrete, and ultra high is a relative term to mean, higher than what you were doing before, which implies optimization, and that applies all the way through. So, you will have to optimize your process to fit it. Step 5, quality control and risk mitigation. The first thing that you're going to have to do is characterize your material. And what I mean is if you're going to try your own material, or even if you're going to buy a bag product, the material has to be characterized. If you're buying a Cientech product or something else, another brand, they will have already characterized the compression strength, the flexural strength, and the durability properties. If you're going to try your own mix, you're going to have to characterize those things because that's what you have to give back to the architect and the owner. If you're going to change the constituents of your mix constantly, you have to recharacterize those things. That's one of the things that is the most expensive about UHPC. Because it's such a highly optimized product, you can't just, tweak this, tweak that, make a million changes and keep going. The AASHTO testing can be very expensive. The know-how, knowing what tests to run, knowing what applications require an amended test. Those are a lot of the things that you want to know up front and characterize your material so there's a level playing field so all parties involved know what to expect. The last thing that you want is an architect who comes in and says, here's UHPC, and they say, all right, so you're going to give me something that's 22,000 PSI, otherwise I don't like it, I don't want it. I will go out on a limb and say I don't think there's an application that anyone in this room will care about 22,000 PSI. This room, the only thing that you're really going to care about is flexural strength and durability, and the compression strength is your byproduct of that. It's the matrix required to get you to that. The testing for those, however, is not entirely straightforward. There aren't a lot of labs who can do it and things like that. That's why you want to make sure you understand that process before you get there. Anchor and insert capacity. Again, we heard yesterday that Tim had to develop an anchor and then get it tested in pull-out and shear. That is not uncommon when you're doing things like this. So you want to make sure that you understand it and qualify it up front. You don't want to be caught surprised when you're down line or have an architect come back with a question and you don't have the answer. Workability. This is a big one. This matters for you to avoid throwing out pieces. The best quality control is being prepared before you got there. So if you know how your material behaves in the heat, you know how it behaves on a dry day, you know how it behaves when you're trying to form the whole thing and trying to get it to flow 8 feet. Understanding that workability is the best tool that you can have to avoid throwing out pieces. Color and consistency. This is still a cementitious composite material. You can use powdered color, you can use liquid color. You just have to know how it rolls into your process with your equipment. The impact of color in a pan mixer versus in a high shear mixer is going to be different, whether it's powder or liquid. So you have to understand color in your application. You want to understand the supply of the material you're getting. The hardest thing for color consistency is, we talk about green here, everybody wants less cement because cement's the devil. I won't get into my feelings on that, but the more things you put in your mix that aren't cement, the more difficult color consistency is. You want to make sure you understand that before taking on a big burden of a project that's over a long time frame or thousands of panels. And then the last one, again, tool in your toolbox, you want to understand the levers you have. For those of you who were there in the fall, you saw some of our white premix mix down at Premier, and it was in the 80s. It was a warm day. They know how the material behaves up to 95 degrees. If it's getting too sticky for them or something of the sorts, they can add ice to that mix. They have other levers that they can do. They could try and pour under a cover like they do, etc. So you want to know If I encounter a problem, what levers do I have? And also remember that once the material leaves your mixer, most of your levers are on the mixer. So you're pretty well stuck once it's out of the mixer. Then there's the routine QC. You'll see here, there's a flow test that you're going to run. You're going to test the temperature, and then what's called visual stability. Do I have an excessive amount of entrapped air? Do I have fiber segregation or floating? Does it look like it's supposed to? And then compression strength. Roy talked a lot about what they've done and the struggles they've found there. But that's something you're going to have to do routinely. Flexural strength, when required, that's not a cheap test. It's not done every single day. Durability properties is something that should be characterized and not tested every time. If your architect is asking you to run durability tests constantly, call somebody that can stand in and help, because you don't want to do that. It's unnecessary expense. Anchor and insert capacity are correlated to your compression and your bending strength. So if you're not hitting your compression strength, you could have problems there, and you don't want a panel to fall off the crane or off the building, right? We want everyone to go home with all the same digits they showed up with. And then also workability. You want to understand how that workability is going to change in different ambient temperatures. Some of you pour in open or semi-open environments. The changes in weather will change that. And yeah, sure, I've poured this material and I've made this shape. Well, now the relative humidity is 15% and not 55%. Can you do it the same way? Best quality control is the 5 Ps. Proper planning prevents poor performance. As I mentioned, if you plan for it ahead of time, you understand the process, you know where your risk is, that's your best quality control before it ever happens. Because everybody has a plan until they get punched in the face. Risk mitigation, and I'll move it along because I gotta wrap up here for John. You want to understand your choke points. Walk before you run. Learn where your choke points are before you try and pour 1,000 cubic yards of the stuff. Ask the questions. Know who your industry resources are and how to leverage them. Roy handed out the PCI book yesterday, works with us quite regularly. He's engaged a lot of other professionals in the industry. Make sure you know what that is before you have a problem and before you need that person to provide you information that will help. Know your levers, and then identify and implement cheap insurance. What I mean is using sealers. You're in the Pacific Northwest, for example, efflorescence is going to happen. Doesn't matter what you think. If you're using a concrete material, you're going to have efflorescence. Mock-ups, etc. Cheap insurance policies. And reflect. We don't learn anything from experience. We learn from reflecting on our experience. Just because you did it does not mean you learned anything if you didn't stop and think about it.
I wonder if you could back up a second and talk a little bit about that. You talked about efflorescence. We had an issue, we're dealing with that right now. We're talking about cleaners, which you suggested, a sealer. Talk a little bit more about what you're seeing with efflorescence in UHPC and how it's being mitigated.
Efflorescence still exists in UHPC. I love UHPC. It's ultra high. It is not perfect. So you will have efflorescence. We recommend sealing. Even if it's not specified, you should work with your architect to tell them either you're going to have efflorescence or you're going to pay for a sealer. The sealers are not all compatible with UHPC, right? UHPC has a much tighter pore structure and matrix, so you do need to make sure that the sealer you're going to try works with UHPC. So you can either engage, with industry, find out what, we've done that works, or you can, call up suppliers, get samples, try it on your panel and see, yeah, okay, this works or it doesn't. The mock-up you have hanging on the back of your building is the best thing you guys could possibly have for yourselves. Try it. It's out in the Pacific Northwest. If it can withstand there, that's the best you're gonna know.
Are you using integral sealer or?
Integral meaning?
That's part of the mix?
No. We don't, at least.
Post-applied.
It's,
Penetrating sealer?
yeah, it's generally post-applied.
And they can penetrate through the fineness of the UHPC?
That's why I say you have to make sure to try the different sealers, because they don't all work on a UHPC matrix. It depends on the size of their molecule, the mix you're doing, etc. But there are sealers that work, and it is a common practice. The other thing that can be done is certain curing processes can help limit your efflorescence as well by stabilizing your moisture and your heat, but that's a bigger, capital investment in a plant type of thing. Does that answer your question?
So it sounds like it's a common issue with UHPC is what I'm hearing you say.
Yeah, it's the same commonality as it is with concrete because it's still a cement-based product and the reaction is similar if not the same. Of course, if you do a white material, it's less prominent because, well, that's the color of your efflorescence. But it all depends on what your architect typically does in that market, what they would accept and what they won't. Yep. And so, quick recap, we talked here about understanding the value chain, selecting opportunities properly, the production process, master craftsmanship, that doesn't change. You still have to put out a beautiful product. And then quality control and risk mitigation. Use your resources. PCI TR 9-22, AASHTO just came out with the design guide. That is intended for structural materials that are strain hardening. There is some material in there that can still help you. Federal Highway has information. If you don't know where to look, that's where your industry resources can help. Improve the process. Roy mentioned, this has been an iteration over a year and a half. Learn, improve, grow, etc. And ask your favorite friendly neighborhood superhero / UHPC enthusiast. That's what I'm here for. So the key takeaways, it's UHPC, but forget that C is concrete. Consider it a composite. It is different. It is not a whole different thing, but it's different enough. Success looks different in every plant and to every architect. And leaders make others around them better. You're on the front line of this thing. You're going to help the industry. You're going to make the architect happy, etc. You're on the forefront. So remember that. And first seek to understand, then be understood. Make sure you understand the process before you try and go and push this too far. And leverage your APA. Thank you.